Hey everyone, let's dive right into today's explainer and explore how everyday environmental pollutants interact with our most complex and vulnerable organ, the human brain. We're looking at some truly fascinating new research detailing not just the damage being done, but the incredible pharmacological tools science is building to fight back.
When we hear toxic threats, we usually picture, glowing chemical spills or massive industrial accidents, right? But the truth is, the invisible threats surround us daily in our own homes and cities, slowly compromising our neural networks. From the packaging that holds our food to the air we breathe on our commute, the exposure is constant and it's completely silent.
To guide us through all this dense material, we'll first identify these silent invaders, see exactly how they attack our neurons, unpack why it's so incredibly hard to detect this exposure early on, and finally, look at the strategies and futuristic tech being developed to protect us.
So, starting with the silent brain invaders, let's pinpoint exactly what these widespread, invisible threats are and where they're hiding in plain sight. What's genuinely staggering here is the sheer variety of everyday sources. Heavy metals like lead and mercury. We know those cause cognitive decline. But look a little deeper. Pesticides from standard agricultural chemicals are linked to memory loss and developmental delays. And then there are plasticizers like BPA and phthalate, causing hormonal disruption. And the primary source for those? Literally the food packaging and plastic containers you probably use every single day.
Take airborne fine particulate matter, for example. We're talking about ultrafine particles, PM2.5 and PM.1. These things are so unbelievably microscopic, they can literally travel straight from your nose right into your brain tissue. Emitted from vehicle exhaust and industrial combustion, they're tiny enough to just bypass the lungs entirely. They ride the olfactory nerve or slip right across the highly selective blood-brain barrier to trigger chronic neuroinflammation. It's wild. Moving on to how these toxins actually attack. Let's zoom way, way in, microscopically, to see how they wage war on your neural pathways once they breach the gates. Once they're inside, these toxins basically launch a four-pronged assault on your central nervous system. They trigger oxidative stress, they spark neuroinflammation by agitating your brain's immune cells, the microglia and astrocytes, they completely throw off your critical neurotransmitter balances, and finally, they cripple your mitochondria. So let's look at how this damage physically manifests, specifically with oxidative stress. Heavy metals and pesticides create these highly unstable molecules called reactive oxygen species. And these molecules literally rust your cellular structures from the inside out, accelerating cell death. Because your neurons have such high metabolic rates and lipid-rich membranes, they are practically sitting ducks for this kind of oxidative degradation. At the exact same time, these invaders are attacking the mitochondria. You know, the powerhouses, the little batteries of your cells. The toxic exposure tanks their ATP energy production, leaving the neurons completely starved. Without that essential energy, the cells simply shut down. And that energy deficit is actually a core driver in severe neurodegenerative conditions like Parkinson's and ALS. Which brings us to the hidden exposure challenge. If this microscopic battle is raging inside us, why is it so incredibly difficult for doctors to just diagnose it and stop it in its tracks? Well, this perfectly illustrates the absolute most frustrating hurdle for toxicologists, the massive time lag. You see, exposure often happens when we're just infants, or even before we're born. But because of this incredibly long latency period, the actual clinical symptoms like cognitive delays or behavioral issues might not finally manifest until years later when a kid is sitting in a classroom. That massive gap in time makes connecting the dots between the original environmental toxin and the present-day neurological damage just ridiculously tricky. Let's pivot to some strategies for brain protection, because luckily it's not all doom and gloom. Researchers in pharmacology are actively building a serious arsenal of medical shields to fight back against this neural onslaught. To fight back, we can deploy antioxidants like vitamin C or coenzyme Q10 to scavenge those reactive oxygen species and neutralize the attacks. Or we can use chelating agents like EDTA and DMSA. Think of these like tiny chemical bouncers. They literally grab onto heavy metals like lead or mercury and physically drag them out of the body through excretion. It's a remarkably targeted way to reduce the heavy metal burden on your neural networks. But not all shields are created equal. Synthetic drugs, like NSAIDs, do successfully block inflammation and can help attenuate memory loss. The catch? Prolonged use carries significant gastrointestinal and cardiovascular risks. On the flip side, natural plant-derived compounds, think curcumin from turmeric or resveratrol from grapes, offer a much safer multimodal shield. They tackle the complex mechanisms of neurotoxicity with far fewer side effects, making them absolutely ideal for long-term preventative care. So, what about the future of neuroprotection? How are modern technology and personalized medicine going to step up our defenses against these invisible threats? The future here is wild. We're looking at AI-enabled wearable biosensors tracking your exact pollution exposure in real time. Imagine a portable monitor alerting you to a spike in volatile organic compounds. Pair that with early blood-based biomarkers, like neurofilament light chain, that can detect neuronal injury way before the damage becomes irreversible. Ultimately, genomic profiling will allow doctors to map exactly how your specific body metabolizes toxins, completely customizing your treatments. They're even looking at nanoparticle delivery systems to drop growth factors directly onto damaged neurons. We are definitely arming ourselves with some incredible science and tech to combat all this. But I want to leave you with this to really ponder. As pharmacology builds us a stronger shield, what can you do today to reshape your own environment and stop these invaders at the source? Think about your household products, your indoor air quality, your daily habits. What step are you going to take right now to protect your brain?